Namaskar. I'm Priti and I welcome you all to our live and interactive session. You are watching us on PME Vidya, channel number 8 and also on our YouTube handle NCERT Official. This session is meant for the learners of class 8 and the subject that we are taking up is science. We are going to learn about chapter number 5 of your textbook titled Exploring Forces Part 2. So, it simply means that we have learned something in the part 1. We will have a brief recap of the same, but before that let me tell you the session is live and interactive, so please feel free to participate. Phone number is 8800440559. Our email ID is tth.class8@ciet.nic.in and on our YouTube handle NCERT Official, you can send us your questions, suggestions and feedback. Now for this chapter and to have an understanding of the concept, we have invited our expert in the studio. We are joined by Miss Priti Maan. Ma'am is TGT Science from Bal Bharati Public School, New Delhi. Ma'am, namaskar and very warm welcome to you.
Thank you.
And we both are accompanied by our Indian Sign Language interpreter, Ms. Bhumi. Bhumi, namaskar and very warm welcome to you too. Now, ma'am, this is Exploring Forces Part 2. I want to understand what we have learned in Part 1 and what are you going to focus on Part 2 today?
Alright, so Part 1 we majorly focused on what is force. So that was a simple definition that we all know. Force is what? That a simple push or pull that happens, right? Then we studied about what are the effects when force comes into play. So what all effects are produced by it. So we have seen that it changes the direction of an object, it changes the speed of an object, it changes the shape of an object, wherein we took the example of preparing chapatis, right? We take the dough, roll it, change the shape and then we further roll it, flatten it into a complete circular shape. Right. So, these are all what? These are the effects of forces. So, when force is getting applied on a body, so what all effects it generated, right? Further, we have seen what are the different types of forces. So, it is classified basically into two major categories, that is the contact forces and non-contact forces. Now, the contact forces we have seen, right, as we go with the name only, contact forces. So, the two bodies are in physical contact with each other, wherein this contact force takes place. So, frictional force is the example of it, right? We have seen that even if we are writing, frictional force comes into play.
Yes.
So, the surface and the pen, right, those two are
coming in contact.
Yes. Same way, muscular force is an example of a contact force. So, to do any of the activities, right, lifting up anything.
Yeah, we are applying the force from the body.
We are applying the force, muscular force, and for applying muscular force, it is seen that yes, the body is in contact. Now, if I lift up anything, right, so muscular force is there, acting there, and me and the object are in physical contact with each other. Now, today we will see the non-contact forces. Now, as we go with the name itself, non-contact forces, what does it mean? That the two bodies where the force is acting, those two bodies are not in physical contact with each other.
Okay.
Okay. So, the first force, that is, it's magnetic force, right? So, we all have played with magnets.
Yes.
Yes. So, what happens when we play with magnets? Now, these are two magnets. Okay. So, different colors. Now, what do we see? Right?
They are attracting
each other. Attracting. Now, if I just twist it, so
nothing is happening.
So, the pink magnet is running away.
Yeah, it's moving, but yeah, not coming closer.
Yes. So, why is that happening? Because magnets has got poles.
Oh.
So, we know North Pole and the South Pole, right? Same way, these magnets have got poles, and we also have seen that the like poles, they repel each other. So, like poles, what they do? They repel each other. So, in this case, when they are not, when the pink magnet is running away from the blue magnet, what does this indicate?
It means that they are like poles and repelling each other.
So, now the poles are facing, it could be anything, north or north pole or south pole. The moment I just turn it and now you just see. Right, without any efforts, the force is coming into play. See, I am not doing anything with this magnet, right? I am just bringing blue magnet near to it, right? And you see the magnetic force is coming into existence, right? So that is what is all magnetic force all about, that yes, the like poles which are north and north, south and south, they do not attract, and the unlike poles, that is north and south, they will attract, and in other case they'll repel each other.
Right, and this is what we see in your PPT also, that
Yes.
attraction is happening, there is repulsion and then there is rotation.
Yes, the green arrows you can see in the
yes.
PPT wherever it is happening, the same thing, the same phenomena.
And ma'am, we see that sometimes a specific kind of charge take place when it comes to clothes, and when we comb something and it gets charged up and it starts attracting things. What's the
Yes.
reason behind that?
See, that reminds me of an activity, right? In our childhood, we used to do
Yes.
scale and rub it on
with
your hair.
yes, paper,
Yes.
little papers.
And that was a sort of magic because it started attracting the paper pieces.
Yes.
What exactly it is? It is what? Again, the charges,
Okay.
right? And the force that is generated because of this is electrostatic force,
Oh,
right? So you have said that dry hair, if you comb,
yeah.
so after a while what will happen, the hair, they get stick to the comb only.
Yes.
Why? Because the hair get charged,
Oh,
right? Same thing happens in winters also, right? Winters, when we take off our clothes,
yes.
woolen clothes,
We see, and we also hear some sound also.
crackling sound
Yeah.
is also produced at that time. Again, that is because of charges,
Okay.
right? So like we discussed with the magnetic force about the poles, how they behave. So the same thing is happening with the charges also. Now in the picture we can see that when it is positive charge, what will happen? Repulsion will
repulsion is
occur
taking
because
place.
they are like charges. Same way, negative,
Repulsion.
repulsion again. No charge, nothing will happen,
neutral.
right? And if it is positive and negative, then attraction will occur.
So in all the cases, only positive and negative means opposite, poles will
Charges,
attract, or
yes.
opposite charges will attract.
In this case, the charges, and in magnetic one,
Is the
it's
poles.
the poles.
Okay.
Yes, only that's the different. Otherwise, those poles and charges, they are behaving in the same manner.
And I think this is the same thing that we see when we put batteries in the devices. Like negative, positive charge,
Yes,
we need to
yes.
have it so that the device runs.
So that's the reason also why if you are putting negative and positive
Yeah.
not at the right place, the
Yes.
device won't work.
Yes.
Why? Because that's the path.
That's the path, right?
So positive you need to put in positive, the circuit gets complete and the charges flow.
Okay.
Okay. Now after this there's one more non-contact force, that is gravitational force. Right. So Newton has discovered this.
Yes.
Apple falling down.
Yeah.
So this is because of which force that happens?
Gravitational force. Yeah.
Okay. So this got discovered. So our planet has this gravity acting everywhere, though the intensity differs, right? On equator, the value of G, when we say that gravity, it is denoted by a G.
Yeah.
So it
Small
is
g?
different. Yes, small
Okay.
g. It is different at the poles. It is different at the equator. But
Okay.
yes, it remains almost same throughout the planet.
So on at the equator, it is intense.
Yes.
Okay.
Right. So all the object, what happens to the object? It goes straight away to the ground. Whatever we are throwing or whatever is falling, it is going straight away to the ground. Why that happens? That happens because of gravitational force.
Okay.
So our planet has that force, right? Over moon, if we compare that.
So you mean to say that it's not just about Earth, but I think different celestial objects have their gravitational forces, right?
Yes.
Okay.
So moon, see, moon is orbiting Earth.
Yes.
That is because of what? Gravitational force that Earth is acting over the moon.
So these both objects are pulling each other, but due to the differences in the intensities of G
Yes.
forces or gravitational forces, they are not coming in contact and hitting each other, right?
So
Okay.
the phenomena also, see, you can see on full moon days,
Yeah.
tides.
Tidal waves are really
Yes,
high,
they
yeah,
are
rising
really
high.
Why? Because of this gravity
Oh.
coming into the picture.
Okay, so because we're getting attracted towards the moon.
Yes.
Okay.
So all those forces, they are interrelated, right? So with this, we are done with the non-contact forces. So
Okay.
we had what? In
Magnetic
this?
force,
Magnetic force,
electrostatic force, and gravitational force.
gravitational force.
Okay. And what next, ma'am?
Now next we have that when this gravitational forces acting, right? What exactly it refers to. So, weight is the term. Now, what is weight? Now, weight is the force with which Earth attracts an object. Now,
Okay.
previously we have said that every object, where it is going? Towards Earth.
Yes.
Right? Now, why it is going towards Earth? Because
It
Earth
has gravitational
is
force.
attracting,
Yeah.
right? Due to its center. Okay. And weight is denoted by what? W, and it depends on the mass. Heavier the object, there will be more attraction towards the Earth.
Okay.
Yes. So, the formula is there on the screen. You can see that W is what? M into G, where M refers to the mass and G is the gravity.
Okay, so my weight, let's say if it's 50 kg, then actually it totally depends on the force with which Earth is attracting me towards it?
Yes.
Okay.
It completely depends on that, because if you go over moon,
Okay.
so you won't remain 50 kgs over there.
Okay, what will be my weight there?
So, we'll see that coming up in the next slides, that how it varies,
All right.
But it do varies, because we say that our weight, yes. So, weight means what? Gravity is also acting on it.
So I think instead of saying this is my weight, I should say my weight on Earth is 50 kg. This should be my complete statement.
Yes,
Okay.
yes, that is the complete statement. Why? Because we say that.
Yeah.
What is your weight? 65 kgs.
Yeah.
Yes, but that is not technically correct.
Next I'll say my weight on Earth is.
Earth is. Because when you talk about weight, so you just are talking about M value, 65 kgs.
Yeah.
Where is that G? G is also there in the picture, right? So this is the, commonly when we talk, so we missed out on these facts. But when you are on Earth, yes, we need to be talking about G also.
Right.
Yes. So mass is completely dependent. So heavier the object, what will happen to it? More gravitational
Yes.
pull. Okay. Now for the next we see it, how do we measure weight? Right. So weight is measured by a spring balance. You can see it. This is a spring balance. Now it shows two values over here, newtons, okay, and grams. Okay. Now how it works is, we need to be fixing it somewhere. With this part needs to be fixed somewhere, and whatever we want to measure. Okay. So there is a scale which gives the value in both the units, in newtons also and in grams also. So we put the object here.
We can hang it here in this pin.
And it stretches,
Okay.
right? And the stretch is proportional to the weight that is being hung here. That
More
is,
the weight, more the stretch.
yes, that is Hooke's law.
Okay.
So whatever amount of weight, see mass, I have told you mass plays an important role.
Yeah.
More the mass, you see more the stretch. If you could see this spring going down, right? So what it gives the value.
Yes.
In newtons also and in grams also. Okay. So what we need to be careful about while using that, when we take the reading, now I have kept it in this position. Now when we take the reading, it should be right parallel to your eyes.
Yeah.
Yes, because the error comes. So when you are seeing the reading, it should be directly right in front of your eye, and then you should see the reading in the spring balance.
Right.
Okay. So what we have measured using spring balance, it is the weight.
And as you said, it's written prevent overloading to avoid damage. So we have like different spring balances available.
Yes.
Because
for different masses.
For different masses, right.
So 100 kgs we cannot put on this.
Yes.
Yes. So we need to be careful with the devices, right? So that's why this point being highlighted, that you should be wise enough to know that what is to be used.
Okay. Now I want to understand one more thing. You've used this term masses here. You know, so you're saying weight, you're saying masses. Weight, I know it is something that I have on Earth. Then what exactly is mass?
All right. So we'll clear that now. The difference between mass and weight.
Okay.
Okay. So mass is what? It is the amount of matter. Like you said that you are 50 kgs on Earth.
Yeah.
Okay. Now if you land up to moon, so your mass will remain the same.
Okay.
Right? Whatever is the amount of matter inside the body, that will remain the same.
Okay.
But your weight will change. Why? Because weight is force of gravity on the object. So the value of G is not same on the moon. So your weight will be 50 divided by 6.
Okay, and that is why people bounce.
Yes.
Astronauts bounce when they are on moon because they feel lighter.
Lighter.
Okay.
So that's the reason, because see, 50 divided by 6, so barely you will have any mass.
Yes.
Any weight.
Any weight on
yes,
moon.
Any weight on the moon, not the mass.
Yeah.
Right. Now for the mass, we calculate in or measure in kilograms.
Okay.
So the mass in kilograms is the right thing.
Okay.
So when we say in kgs, we are exactly measuring the
Mass. Okay.
not the weight.
Okay. And what's the SI unit for weight then?
That is for Newton, because we said that it
Oh.
is what? It is a force,
Wow.
right? So that is the weight, the unit there is Newton.
Okay.
Now mass is constant everywhere. So whatever is there inside your body, you go to equator, you go to pole, you go to moon,
Yes.
and that too on any other planet, the
True.
mass will remain the same, right? But if we talk of the weight, so weight will change because the value of G is changing. On Earth it is different, on moon it is different, on Mars it is different. Now if you see in the picture, I have given the comparison that mass is 50 kgs, but weight on Earth it is 110 and weight on Mars it is 42. So even when you are going over Mars, so you will be weighing less than on Earth.
Right.
Okay.
And I was about to ask this thing also. I think the last point mentions it, that okay, I now understand how do I measure my weight? We have spring balances, we have weighing machines and etc. But how do I measure my mass?
So with the help of beam balance. So the picture is given there. So with the help of beam balance, we measure the mass.
So I think I need to go to these Roshan shops where they have huge beam balances. Let me sit there and get my exact mass.
Yes.
Okay.
Yes. Okay. So weight, we have seen how it is measured. It is measured with the help of spring balance.
Yeah.
Right.
Okay. And after that, we are going to learn about another important concept.
Yes.
Okay.
So we'll see about.
Because there is one more important concept which generally is associated with weight and mass. If I'm not wrong, it's the buoyant force.
Right.
Right, and Archimedes had his eureka moment also. So I want to listen to this story.
Okay. So buoyant force, like you said, right? So we'll first technically understand what it is.
Yeah.
Right, because Archimedes also, he was in his bathtub when he got the answer to his question.
Oh.
And he went running straight forward to the king's palace.
Court.
Yes, to tell the answer of it. Okay. So first we'll see what exactly is buoyant force. Now by that time we can have a look at the definition. So what the definition says, that it is upward push exerted by a liquid or a gas. So generally we talk of fluids.
Yes.
Okay. On an object immersed in it.
Okay.
Fine. So say this is an object and I placed it in the water. Right. Now what will happen if I try to push it in water? Right. So you can see it is bouncing back.
Yes.
Because there's some sort of force that is being applied by the fluid.
It's pushing it
also.
upward.
Yes.
Yes.
I am pushing it downward, but it is coming, it is bouncing back.
Yeah.
So why is this happening? Because the liquid inside is also exerting
force. Okay.
and that force is perpendicular, right? So if say I am also applying force that is perpendicular, and as a result I am getting the buoyant force which is coming from the liquid. Okay. So one more thing is why it is happening. The cause is what? The liquid is exerting pressure in all the directions, and more is the depth, more is the pressure that is exerted by a liquid.
I think that is why sometimes it happens when a person drowns in water, he or she doesn't drown immediately. The person, if the person is not a swimmer, the person comes upward again and again. So that's the buoyant force acting on the body.
Buoyant force acting, but then what happens when the object sinks? We'll see that also. Now in this case, right? In this case, what is happening? The density of this object is less.
Yes.
Now if I take some other object, say if I take this is a metal ring. Now what has happened to it?
Oh, it drowned in the water.
It sank inside. right? Because the density of the ring is more than that of water.
Okay.
Right? Now, what Archimedes has found out, right? So, that's a very interesting story. Children should go and find the story, because we all study about Archimedes' principle.
Yeah.
So, he was given a task, right? He needs to find out that the goldsmith has made a crown for the king.
Okay.
So, whether, and the king has given some amount of gold, right? So, say 4 gold bars.
Okay.
So, he wanted to check whether the crown, in the making of that crown, all those 4 gold bars are
Have been
utilized.
used or not?
Yes.
Oh.
Or is there any sort of adulteration?
Okay.
So, how to find out? So, exactly density he wants to find out, mass he could get, but the volume was the problem.
Oh.
Right. So, when he was taking bath, the moment he sat down, so what he found, that some amount of liquid got displaced.
Came out, yes.
Yes, the liquid came out, right?
Yeah.
So, that's the moment when he found out that yes, same thing I can do with the crown also. I can just put it in the water. The volume that will come out, the liquid that got displaced, I can measure that volume. And I can put that in the formula and find out. And what he found out, that yes, goldsmith has done something wrong. Okay, so that was the whole story where he got his eureka moment.
Yeah.
Now, what are the factors which are affecting the upthirst here?
Yeah.
That is the density of the liquid. I've told you, if it is not water, if it is some other liquid, so how these both the objects are behaving, that will change.
Sure.
Yes. And second is the volume displaced.
Yes.
Now, the next is floating and sinking.
Yeah.
Right. So, we have seen that when the weight is more than the upthirst, right, the object sinks.
Yes.
So, the ring has more weight
Yeah.
than the weight of the force exerted by the liquid. So, it sank down. Okay. And if the weight is equal to upthirst, in this case, what is happening? It is not going down. Even if I am trying hard, it is bouncing back.
Yeah.
Right. So, in this case, what will happen? The object will float.
I think it has something to do with the surface area also, because ships, they're wider, so they sank.
Yes.
And
So, what happens in this case? We talked of the liquid displaced.
yeah.
So, they are displacing larger amount of
Okay,
liquid.
okay.
Yes. So, even a small hole can make the ship go down in
Go
the
down,
water.
yes, yeah.
Why? What will happen in that case? Because water start entering.
Oh, achha.
So, this is a very good chapter. Now, you will find very like nicely aligned numericals to it
Yeah.
also. Students should practice those.
Absolutely. You must figure out why boats are able to float on water and they are not sinking down, and what is the relation here between the weight and the density of the water. So, because we do not have enough time, but it was a fun activity and we had a eureka moment here in the studio also. So, thank you so much for your
Thank you.
time and contribution to the session. I would also like to thank my ISL interpreter, Ms. Bhumi, for her contribution to the session. Thank you so much. So, Exploring Forces Part 2 has come to an end, and with this it's time for me to give you quick updates regarding textbooks. They are available on Amazon, Flipkart and NCERT website for grade 4 and 7, and simultaneously take a quick look at the schedule. In a short while from now, you can watch another session of ours, which will be on mathematics. We will learn about algebraic expressions and entities, followed by our online training program at 4 p.m. and we will end the day with our session Sahyog. With this, it's a wrap. This is me, Priti, taking leave of you, and will join you shortly. Namaskar.